Okay, this is the last section for solving linear systems before we move on to systems of inequalities. So today we're going to be talking about number of solutions and classifying linear systems. All right, up to now, every solution to a linear system was an ordered pair. But through our conversations, you know that there are two other types. So we have the intersecting, so the lines are intersecting. And I'm just going to give an example on a graph. So they're intersecting. And you know that the number of solutions is 1. It's that point of intersection. It's an ordered pair. I'll talk about the classifying in just a minute. We also know that there are parallel lines, like that. And since the solution is where they intersect, this is a no solution. And then we have coinciding lines. Coinciding lines means that they're the same line. So once you graph them, you get the exact same line. And so since every point is the same, we say there are many solutions. So some of what you're going to be practicing today is just naming the number of solutions based on the type of lines, and hopefully you'll be able to notice that in equations as well, because parallel lines have the same slope but different y-intercepts in the equation. Coinciding has the same everything. Once you put them into the y-intercept, they're same everything. Same everything. Where intersecting lines may have the same y-intercept, but they have different slopes. Different, I hope you're writing neater than me, slopes. All right, so let's talk about this last part, the classifying. Some of what you're going to be doing today is classifying, and so we can classify a system either as independent or dependent, consistent or inconsistent. And this is how I think of it. It's independent if there's two separate lines. So independent, they're two separate lines. They're either intersecting or they're completely separate. These two are exactly the same though, so they're dependent on one another. They're dependent on one another. And the other way is consistent or inconsistent. Now, I'm not sure who came up with this vocabulary, but this is how I think of it. We think of a solution to a linear system as an ordered pair. And this, with one solution or intersecting lines, is consistent with that thought. There is one ordered pair, so it's consistent. An ordered pair is a solution. Here, when there are many, now we have many ordered pairs, so it's still consistent with our thought. There is an ordered pair as a solution. There's just many of them, so it's consistent. And this one, though, there's not an ordered pair, so it is inconsistent with our thought. Now, I'm not sure that that's where these came up with, but that's how I think of it. The two lines are independent from each other if they're two separate. If it's the exact same two, they're dependent on each other. They're consistent if they have at least one ordered pair. They're inconsistent if they have no ordered pairs. All right, determining if there's one solution, no solutions, many solutions, consistent or inconsistent from a graph means you need to draw them out first, okay? So I just want to remind you, you've already been tested over this, but first you need to put them into slope-intercept form. So here we have y equals 4x plus 2. So I'm going to go to the 2, and I'm going to go up 1, 2, 3, 4, and over 1. Down 1, 2, 3, 4, over 1. Now it is more difficult, as you can see, to make a straight line when you do not have a ruler, so use a ruler. Here I'm going to do minus 12x, subtract 12x, so I have negative 3y equals negative 12x minus 6. I have to divide everything by -3. This is a good review for those of you that didn't know how to solve by graphing. Y equals 4x plus 2. At this point, I can see that these are identical, so I know that the lines are going to be identical, which means they are coinciding. So you would say coinciding, that's the type of line they are. There's many solutions, and to classify them, we know they're dependent on one another because they're the same line, so they're dependent on one another, and it's consistent. They're consistent because, and again, this is the way I think of it, there is an ordered pair, just like what we have been saying and thinking. There is an ordered pair, so it is consistent with our thoughts, but they're dependent on one another. Hopefully you took really good notes, because what I would like you to do next, instead of giving you a handout, and these are your IXL homework categories for tonight.